Hello, children. Hope you all are fine and doing good by the grace of God. So, we have completed 7 units. So, we are going into a new unit, which is Unit 4 Electric Charges and Electric Current. So, this is part 1 video. So, we'll move on to the motivational quote for the week. Go confidently in the direction of your dreams. Live the life you have imagined, said by Henry David Thoreau. I'll repeat it again. Go confidently in the direction of your dreams. Live the life you have imagined. Yes, my dear students. So, yes, chase your dreams with confidence and you'll reach greater heights. With this quote, we'll move on to today's lesson. The topics to be concentrated in this session are electric charges, electric force, electric field, electric potential, and electric current. So these 5 terms which come under electric, right? So these 5 terms are very important and you need to listen carefully to this video to know what all these terms relate to. So yes, children, listen carefully. We'll quickly move on to the class. Yes. So like mass, length, electric charges, we have studied this term somewhere, right? Yes, we have studied in Unit 1, measurement. We studied the SI unit of each things, right? Yes. So like mass and length, electric charges is also a fundamental property of all matter. And we know that matter is made up of, yes, atoms. So what is this model? It is a structure of an atom. And we know that there are 3 subatomic particles. So what are the 3 subatomic particles? So by nature, we know proton has positive charge, neutron has no charge or it can be said as neutral charge, and electron has negative charges. So hope you're clear with this atom. So how can it be related, how atoms related to electric charges? Yes, electric current is nothing but flow of electrons. So atom plays a major role in electric charges. And in today's world, without electricity, we can't ever live, right? If there is a power cut for 1 hour, we just swept for a long time and we feel uncomfortable to stay in, right? Yes, so electricity is a very important source in energy in this modern times. So we start with an activity. So take a comb and you're going to rub on your dry hair, okay, and you're going to make the comb to attract small pieces of paper. Does it attract? You need to say it, okay? Try it out, this activity at home. So I'm going to give the principle behind this activity. So when you rub the comb vigorously, electrons from your hair leave and accumulate on the edge of the comb. Your hair is now positively charged as it has lost electrons, whereas comb is negatively charged as it has gained electron. So this is the basic principle of this activity. So try out this activity at your home, children. So next topic we are going to see is measuring electric charges. So electric charge is measured in coulomb and the symbol for the same is C, capital C, okay? And the charge of electron, we have already seen that the charge of electron is 1.6 into 10 power minus 19 coulomb. So Q is equal to Ne. This is what we measure, okay? So this indicates that any charge Q has to be an integral multiple of this fundamental unit of electron charge. So Q is equal to Ne, where N is the whole number and E is nothing but the charge of electron. So we'll see one problem. How many electrons will be there in 1 coulomb of charge? So we are going to calculate it. So we know that charge of 1 electron is 1.6 into 10 power minus 19 coulomb. So we know the formula as well. So what is the formula? Yes, Q is equal to Ne. So we need to find number of electrons. So it can be framed as this formula can be framed as N is equal to Q by E. So when you substitute the given data in it, you will get N is equal to 1 by 1.6 into 10 power minus 19 coulomb. So Q is nothing but we are in the question they have given us 1 coulomb. So we mentioned it as 1, and number of electrons we know that 1.6 into 10 power minus 19 coulomb. So thus we can find the number of electrons, that which is 6.25 into 10 power 18 electrons. So how many electrons will be there in 1 coulomb of charge? So there will be 6.25 into 10 power 18 electrons will be there in 1 coulomb of charge. And we know that electric charge is additive in nature. The total electric charge of a system is the algebraic sum of all the charges located in the system. So when you consider an example, if you have two charges, okay, we have taken as two charges named as 5 coulomb and minus 2 coulomb. So one is positive charge and another one is negative charge. Okay. And this statement says that electric charge is nothing but the total electric charge of a system is the algebraic sum of all the charges located in the system. So we need to add it. Okay. So plus 5 coulomb and plus minus 2 coulomb, which gives 3 coulomb. Therefore, electric charge is additive in nature. The next topic we are going to see is electric force and electric field. We'll consider a magnet, okay? In magnet, there are two sides, right? One is North Pole and other one is South Pole. When you take two magnets, okay, when you take two magnets and when you bring together closely, what happens if it is in like poles? That is, if we bring the north side of one magnet and the north side of another magnet nearby, it repels. So like poles repel, whereas unlike poles, when you bring the south side of one magnet and the north side of one magnet, it gets attracted. So like poles repel, whereas unlike poles attract. Yes, and there are two forces behind it. The two types of force are attractive force and repulsive force. So why this is getting connected with electric force? Yes, so the force existing between the charges is called as electric force. See here, the first image, which is a neutral objects, they neither attract or repel. In the second image, it has negative electron and positive proton. So they attract. Oppositively charged objects attract. Yes. So among electric charges, there are two types of electric forces. They are attractive force and repulsive force. So we saw in magnet, right? Same thing comes under electric force as well. So like charges repel and unlike charges attract. And next important thing is we are going to see about electric field. So what is an electric field? The region in which a charge experiences electric force forms the electric field around the charges. Yes, often electric field E is represented by lines and arrowheads indicating the direction of electric field. So here in this image you can see that the lines has been directed by the arrowhead, right? So this is the arrowhead and the lines have been directed towards, and the arrowheads indicating the direction of electric field. So these lines are said to be electric lines of forces. So what is electric lines of forces? The electric lines of forces are straight or curved paths along which a unit positive charge tends to move in the electric field. So electric lines of force are imaginary lines, okay? It is an imaginary lines. The strength of an electric field is represented by how close the field lines are to one another. And this electric field at a point is measurement of force acting on a unit positive charge placed at that point. So a positive charge will experience force in the direction of electric field and negative charge will experience the opposite direction of electric field. So next we are going into an important topic which is electric potential. So though there is electric force, like we have seen two electric forces, right? What are the two electric forces? One is attractive force and another one is repulsive force. So though these electric force existing among the charges, they are still kept together, is it not? We know that in the region of electric charge, there is an electric field. Other charges experience force in the field and vice versa. There's a work done on the charges to keep them together, and this results in a quantity called electric potential. So what is an electric potential? What would be the definition of electric potential? Electric potential is a measure of the work done on a unit positive charge to bring it to that point against all electric forces. Okay, so I have given you the level diagram, which is higher potential and the lower potential, how the energy flows. Okay, so this is what electric potential. Next, we are going into an important topic, which is electric current. So when the charged object is provided with the conducting path, electrons start to flow. And we know that when electrons move, we say that electric current is produced. So that is, an electric current is formed by moving of electrons. So in this image here, when you pass large current, many charges will flow. Okay, whereas when we pass a small current, only few charges are flowing. So this image tells us clearly, right? So in the first image, which is the red color portion, it shows that a large current is passed. Then there will be many charges flowing in that system. Okay. Whereas in this blue image, okay, you can see that a small current is passed and you can see only few charges flowing in that particular direction, in that particular system. So when the electrons move, of course, electric current is produced. And now we are going to see about the direction of electric current. So before the discovery of electrons, scientists believed that electric current consisted of moving positive charges. But it is wrong, we know that, right? The electric current is basically the movement of electrons. But before the discovery of electrons, the scientists were believing that the electric current is produced by the moving of positive charges. But though this idea is wrong, the discovery of flow of electrons did not affect the basic understanding of the electric current. Okay, so the movement of the positive charge is called as conventional current. You may wonder, where does this positive come from? In battery, we have positive electrode and the negative electrode, whereas the negative electrode only travels outside the circuit and positive electrode inside this battery will remain flow inside the battery itself. Okay, so here this current is said to be, the positive charge current is said to be conventional current. Okay, and the flow of electrons is termed to be electron current. So in many electrical circuits, how can we represent this electric current? There are two types. One is cell and battery. So cell is different and battery is different. Okay. So in electrical circuit, the positive terminal is represented by a long line and the negative terminal is represented as a short line. So battery is nothing but it is a combination of cell. So cell is single unit. Okay. Cell means it has only one positive terminal and one negative terminal, whereas battery has a series of cells. It can be 2 or 3 anytime. Okay, so battery is a combination of more than one cell. This is the difference between cell and battery, and this is how it is represented in electrical circuits. Next, we are going to see measurement measurement of electric current. How can this electric current be measured? Okay, we can measure the value of current and express it numerically. So current is nothing but it is the rate at which charges flow past a point on a circuit. Okay. Yes. So we see that current is the rate at which charge flow past point in a circuit, and it is denoted as I is equal to Q by T. And its SI unit is ampere. This symbol is A. And how it is measured? 1 ampere is nothing but 1 coulomb by 1 second. And this is the image of ammeter. So the instrument which is used to measure the electric current is ammeter. So this is how the setup of ammeter. Okay, this you can see in physics lab when you come to school. Okay. And the readings of ammeter can be noted down. It also shows readings like this, and this instrument is used. You would have seen most of our equations to measure how much current is there in the system. Okay. Next, so this instrument is termed to be ammeter. So instrument which is used to measure the strength of the electric current in that electric circuit. And here I have given you how the ammeter can be connected in a electrical circuits. Okay, so ammeter is loaded here. Okay, it is connected in series in a circuit when the current is to be found. So the current flows to a positive red terminal of ammeter. So ammeter has two terminals. One is positive red terminal and the negative black terminal. So the knob which denoted in red color, it is a positive terminal, and the knob which denotes in black color, it is a negative terminal. So the current flows to the positive red terminal of ammeter and leaves from the negative black terminal. So this is how the main setup will be. So there will be load and ammeter, then a battery. So this is how the current flows through an ammeter, and the readings will be noted in ammeter. Next, we can see a problem related to it. So the problem question is, if 25 coulomb of charge is determined to pass through a wire of any cross section in 50 seconds, what is the measure of current? As I've already insisted how to attend problem, first write down the given data. First read the question twice or thrice and write down the given data. So here they have given charge, which is Q is nothing but 25 coulomb, and 50 seconds, which is time they have given. And we know the formula that I is equal to Q by T. So current, how to find the current? So charge divided by time. So very simple. So you are just going to divide 25 by 50. Okay. When you divide 25 by 50, you will be getting 0.5 ampere. And you know the unit of current is ampere. How does this ampere comes from? Whereas the charge Q holds the unit coulomb and the time holds the unit second. So coulomb per second it can be written as ampere. So for this problem we got the answer. How much measure of current we got? It is 0.5 ampere. Hope it was clear to you. So that's it, my dear students. Let's recall what we learned in today's class. So we started with new unit, which is unit 4, electric charges and electric current. So under that, first we saw about electric charge. So what is electric charge? Electric charge is measured in coulomb and its symbol is denoted as capital C. And the charge of an electron, we know that 1.6 into 10 power minus 19 coulomb. And how to calculate this electric charge? So they have given the formula Q is equal to Ne, and where N would be the whole number. And next we saw the electric lines of forces. So what is an electric line of force? The electric line of force are straight or curved paths along which a unit positive charge tends to move in the electric field. So it is denoted by the arrowheads, right? And this arrowheads denotes the direction of current. And next we saw about electric potential. So what is electric potential? Electric potential is a measure of the work done on unit positive charge to bring it to that point against all electric forces. Next, current. So what is current? Current is the rate at which charge flow pass point in a circuit, and it can be used as a formula for I is equal to Q by T. To measure current, the formula is I is equal to Q by T. And the SI unit of current is ampere and its symbol is A. So hope you are clear with today's class, children. So for your follow-up work, I'll be giving you two sums, okay, two problems. So as I've already mentioned that when I give you some problem, just relax yourself. First, read the question twice or thrice, then write the given data, then relate which formula suits the best, then you can find the answer. So try it out carefully, and once you have done this two problem, upload it in Google Classroom. So first one is 300 coulomb of charge is passing through a wire. It crosses a point on the wire in 60 seconds. So find the current flowing through the circuit. The second question is, the current flowing through a lamp is 0.2 ampere. If the lamp is switched on for 1 hour, what is the total electric charge that passes through the lamp? So work down these two questions. Once you get the answer, take a pic of it and upload it in Google Classroom, or you can send me in WhatsApp. Thank you so much, children, for patiently listening to the class. Stay home, stay safe. May God bless you.